Welcome everyone. Today we will see how to create a linked list. In the previous presentation we have seen that what is a linked list and how it is represented. We use the approach to identify or represent the endpoint in the linked list, and that is the last node will have the pointer value 0. So if you see a linked list given here, then it is having total 2 nodes. This is the start or the first node. The item value is 20 and the next pointer value is 7008. That is the address of second node, and that node is having item value 20 and the next value 0 or null, because it is the last node. No more nodes are available. So in this list we are having only 2 nodes. So now let us write C codes or C statements how to create a linked list of total 2 nodes. Before that, let us see how we will represent our linked list. So for that we are using a structure linked list. In that we are having data part, that is integer item, and struct linked list pointer next. This is the definition of struct linked list. So remember this. We are going to use this for our next programs and next discussions. We are also changing the name of struct linked list with node by using type def. So we are writing type def struct linked list. We are changing the name as node. So now onwards, whenever we write node, the meaning of node is struct linked list. Creating a linked list. Initially, we may not have a fair idea about total number of items, how many items will be there. That's why we opted for the dynamic data structure, that is a linked list, instead of array, of course. Usually we create linked list initially having one node as the end node. You can refer to string as a character array with only one byte and the first byte as null. So we will create a linked list with one node and assuming that it may be the end node if the linked list is empty. Recall the student registration problem we discussed. We start to write, or we sit to write a list of candidates who are coming for registration. But if no one comes, then our list will be empty. No person comes for registration, our list may be empty. So that is the same structure definition written here. Okay, what we want to do, we want to create a structure linked list for 2 nodes. So create pointer to the node data type, say head. That will be point to our first node. So node pointer head, that is our first statement. In second statement, we will create a storage for that node. Head is equal to node pointer malloc size of node. So this will allocate total the memory required by one node, that is this one structured variable, because node is nothing but struct linked list. So it will allocate memory for this, assuming 2 byte and a pointer 2 byte. So total 4 byte will be allocated and a pointer will be written and it will be stored by head. So in first we create a head. First step we create head. First step we create pointer head. Second step we create memory. So in second step we create this memory. In third step, now ask user to input the data value, that means this item value. Item value we want to enter, and tell the user that you enter minus triple line to indicate the end of item values. So we will keep on scanning the values and ask user that at the end you enter minus triple line. So we print enter the items values minus triple line to indicate the end of list. The fourth step, we read this value in item, so that we write scanf percentage d head arrow item. We know that if we want to access the element of structure by pointer, then we use arrow operator. So if this is the structure and pointer to the structure is head, then we can scan this item value by writing head arrow item and head arrow next. So we know that with pointer we are using the arrow operator. Head arrow item. And in the fifth step, we know if this item value is suppose say 20, that means here 20. So of course this is not going to be the last node because it is having a value 20. So user still wants to continue entering the next node. So the fifth step will be the item value is other than minus triple line. So we need to create a new memory for the end node. So this is not end node. So the next node may be the end node. So again create a space and repeat the step using step 2 now utilized by the list item. So if head arrow item is not equal to minus triple line, then we create a new memory space and this address of this will be saved at the next value of this. So head arrow next is equal to new memory. So head arrow next is equal to new memory. Now here it's just a revision. The first step, node pointer head. Second step, head equal to memory, so this memory. Third step, printf. Fourth step, scan the item value, that is 20. Fifth step, we create, as this 20 is not minus triple line, we create one more node and this value will be assigned to head arrow next. So this will point to the new memory location, head arrow next equal to this. Now we need to repeat the step 3 to 5. This steps we need to repeat. Enter minus triple line at the end, scan the value for this item, and then if it is not minus triple line, create a new node. So this 3 to 5 step will keep on repeating. However, in step 4, if you see that input is accepted for head arrow item. So here we have head arrow item. So this we have scan the value. Now for this node, if we repeat the steps, then if we scan the value at head arrow item, then it will override this 20. So when we are scanning the value of this node, your head should be pointing here. So your head now will be changed to head is equal to head arrow next. So now your head will become this. So we need to write head is equal to head arrow next before repeating 3 to 5. So again, the same step. Here we'll write if it is not minus triple line, head arrow next is equal to new memory and head is equal to head arrow next before repeating step 3 to 5. The link established by 2 is now broken. Go to step 3. So now we are going to step 3 and we will scan again this and this we are doing. But okay, the program continues. Same steps 1, 2, 3, 4, 5. Here we are writing if head arrow item is not equal to minus triple line, and then what we need to do? We need to create a space for the next element. Then we write head is equal to head arrow next, so that your head will move to the next element, and we can scan the values this. But one thing we need to note here, that your head, when we are writing head is equal to head arrow next, your head is pointing here, and this link which we have previously established is broken. That means head which was pointing to the first element is now broken. So that we need to take care. In the else part, we are writing if the entered value is minus triple line. In the else part, we will make head arrow next is equal to null, which will indicate the end of linked list. Suppose the program or the steps you repeat in which your loop rotates only one time, then you are scanning 20 and then you are entering minus triple line, so it is only first repeat. In the first you are entering 20, second you are entering 30, then again it will create a space, so it is a 2 times repetition of the statements will represent link like this. If we discuss the issue created by the statement head is equal to head arrow next, where we are breaking this link, how we can resolve this? So for that, what we can do, as soon as we create head which points to the first element, we create one more variable, that is node pointer first, and we can make node pointer first equal to head, so your first is also pointing here. When your head points to the first element, the same time your first variable is also pointing to the first element. So even though your head is now changed, we can still get the first element by using the pointer first. So with this we can always access the first node using the node pointer first. This is the program. Now we will compile all the statements that we have written or we have discussed till yet. This is the definition, type def, the steps, 2 pointers we are creating. This is the memory allocation for the first node, first equal to head to secure the head value. Now enter this value minus, we are printing statement that enter value and enter minus triple line to indicate the end of list. Now this we are writing as a loop, as a repetition statement. Scan the value. If the value is not minus triple line, create a new node, make head is equal to head arrow next, and continue from here. It will repeat. If the enter value is minus triple line, you go in else, and that indicates the end of linked list. So from here, your program will terminate. You can replace this loop or representation of goto with while and do while. While and do while, we are just replacing the goto statement with while do while. The statements are same, you can see. Just alternate for goto loop. One is while, one is do while. Now we will modify our linked list creation program using recursive function. or you can say now we will write this, or we will create a linked list using a create function. And in create we will pass the head pointer, that is a first pointer. So now we are passing the head pointer in the function. So here that head pointer will be just copied in the list pointer, copy the argument by the calling function. So that head pointer will be copied in the list, and now we will write the statements that we have written for creating a linked list, the statements in the function. Enter the value, scan the value. If it is not 999, create a new node, list equal to list arrow next, and here create list. So again, this is the recursive call. It will call the list function with modified value of list. So now as list is equal to list arrow next, so this pointer is now pointing to the second node and will call create. So now again printf, scan the second value. If it is not minus 999, create a node for create a space for third value, change the list, and again call. Now if you enter minus 999, then it will not go in this if part, and it will go in else, and it will make list arrow next equal to null, and your recursion call will stop. Here list equal to list arrow next and create list, this two statement you can combine by writing create list arrow next. This is optional, you can write this two or you can write one statement. Remember, declare create function in main first. Second, the address of first node is stored in head pointer. Since it is passed by the value to create, its value not change. Therefore, no need to preserve the same using the other pointer variable in main. We have passed the value of head while calling the create function from main. We are passing the head value here. Okay, that is copied in list. So we are performing all operations on list. So our head is not changed because a copy of head is just preserved in, or it is saved in list. So our head is not changed and it is as it is. The same thing is represented using flowchart. Allocate memory for first node, call create using the head, pass the head. Here accesses the node address pass by calling the function, take the item value. If that item value is minus 999, then referred node is an end node and stop. If it is not minus 999, allocate memory for new node, put the address of new node in the field of node being referred. That means list arrow next equal to malloc, call the create using list arrow next, and again repeat from here. Now comes printing of linked list. So we have seen how to create the linked list. Now we will see how to print the linked list. We know that we have the starting of linked list in the first pointer or the start pointer. So what is important, the print list, suppose we write a print list function, then the print list function will start printing all the list values starting from the first node. For that, the main need to supply the address of first node to the print list function. The address of first node is already with main function in form of head pointer, so that we already have. The second, the print list will print all the nodes till it finds the end of node. The end node has stored value of minus triple nine and the null pointer value in the next pointer field. Third, it means print list will call itself till it finds the end node. We can use the recursive approach. So let's look at the definition of print list. In print list, we will pass the first pointer, that pointer, first or head pointer. The head pointer will be copied in the list. Now, if list arrow next is not equal to null, means if it is not the last node, printf the value of item and call the print list with list arrow next means the next pointer. So again it will go here. If the second node and second node next pointer is not equal to null, print that value. Again call the list arrow next, it will print the third node, then it will print the fourth node value, then it will print the fifth and so on. Now when it comes to the end, if list arrow next is not equal to null will be false and it will go in else and it will print end of node item value percentage %d and list arrow item. Now can you guess that when list arrow next is not equal to null false, that means the value of list arrow next is equal to null and it goes in else, so what will be the value of percentage %d printed here? So you need to guess what will be the value of percentage %d when it goes in else. Now you need to write appropriate main combining the create function and the print list function discussed before. Write a program and try to see the output. I have already done this. I will show you the video of the program, how it is executed, and you can see the output. Okay, this is assignment. Definition of main function is given. In the main function you have head pointer, create and print list. This will create the linked list, this will print the linked list. Now you have to write a count function in which you are passing the head pointer, which will count the total number of nodes available in the list. That is the first function. Second function is print element head number. You have to print the list item at number position. For example, I call the print element head comma 3. Then you have to print the list item at third position. So in your linked list you have node 1, node 2, node 3. So you have to print node 3 value. Count element, that is a third function you have to write, in which you are passing head and key, which will count total list items having stored value is equal to key. So you know that in your linked list we are having item value and the next pointer. So suppose I write count element here, comma, key value as 20. So you have to count how many number of nodes in your linked list having the item value is equal to 20. So in your linked list, if you have 1000 nodes, from the 1000 nodes, 5 nodes item value is 20, then the output of this function should be 5. Total 5 number of nodes having the item value 20 because I entered the value of key as 20. So you have to define all the functions and you can email me your work with count function, print element and count element. You can do one function at a time. First only concentrate on count. First finish this, then you finish print element, then you finish count element. Thank you.